go. Florida, wow.
So we are now live on YouTube. Hello, YouTube friends. Welcome back to Insider's Guide to the Galaxy. I think we're episode 51 now on this hopefully nice spring day for some people. Maybe some people seem to still have snow. We have a fun moon topic today. We're going to do a deep dive in one of the Mare or seas. I forget. And so if you don't know me, I'm Samantha. I am with Ross National, and Chris Vaughn, our star of the show here, I'll let him take it away and announce what we're talking about today.
Yeah, we don't typically introduce ourselves. So yeah, I'm Chris Vaughn. I'm a member of the Toronto Centre. So I'm a volunteer and happy to do this for everybody. All right. So what we're going to do today is, because the moon is up tonight, it's been up all week, I thought it'd be a great opportunity to do an observer's guide to a section of the moon. And I picked the Sea of Serenity, Mare Serenitatis. And then when we're done that, we'll leave a little bit of time at the end to do a couple of Messier objects. All right, let me just share my screen here and get started. Here we go. And move the little Zoom people out of the way. Perfect. So here we've got the, let me just get a full screen here. I think this will work for me. There we go. So here's the scene tonight I'm using primarily going to use Starry Night software to do this today instead of Stellarium, just because the Starry Night package offers me a variety of views of the moon that you don't get in Stellarium. And I'm also going to use another tool from NASA, which we'll switch to in a little bit. But just to start off a little bit about the moon and some new moon nomenclature. So a lot of the main features of the moon that we're used to hearing were coined by a Jesuit priest / astronomer named Giovanni Battista Riccioli. And in 1651, and he collaborated with another person named Cauchy, who you might be familiar to if you looked at some of the features on the moon. And they published a moon map, which is here. Let's bring this into the front. And you can see that we have all these features, and they're labeled in Latin. What he did is he used a philosophy where he assigned the names of craters to scientists and their sort of pupils, and he put the more ancient ones, sort of the Greek and Roman philosopher ones, in the north, and he put the sort of more modern contemporary ones in the south. And then he took the ones that were causing a fuss with the church, the ones that were promoting the heliocentric model of the solar system, and he put them over here in Oceanus Procellarum, which is the Sea of Storms, because of the stormy weather they were creating. So that's where you find Copernicus and Kepler and a few of the other ones. The craters, as I said, are named after scientists. The dark areas, which at the time they thought were oceans because they were dark and they seemed flat, and nobody had telescopes before. They had telescopes by his time, but by the time they were declared to be mare or seas, people hadn't pointed telescopes at the moon yet. And so they're named after weather systems and people's moods. So you've got the Mare Nubium for the Sea of Clouds, and you've got Mare Frigoris, the Sea of Cold, and Mare Crisium, the Sea of Crisis. And then today's topic here, Mare Serenitatis, or the Sea of Serenity.
Glad you picked a calm one for today. No crisis.
Yeah. Well, I did this because it's kind of a nice case study for a lunar basin. So what these dark mare are, in fact, are actually lava or basalt flooded basins or depressions that were carved out by giant impactors early in the moon's formation history. Let me just put this one away. I'm going to switch over to a moon here. Let's see. Moon features labeled. Here we go. I'll just zoom back a little bit. And you can see that, you know, some of them are kind of clearly round. Other ones are a little bit more amorphous, and that's because they were, you know, formed in sequence, one before another. And as the new ones were formed, then they would partially obliterate or partially overprint the older ones. And so the Sea of Serenity, which is labeled up here in the middle, it was formed in the so-called Nectarian age, which is around the time of the Mare Nectaris was formed, about 3.6 billion years ago. And so it would be after the formation of Mare Nectaris and after Mare Humorum. Let me see if I can find you another view where we've got the different, I've got some different scenes here of the Mare regions here. How about this one? There we go. Yeah, so this is kind of a clearer picture of it. So you've got Mare Serenitatis here in the middle and Mare Tranquillitatis, Mare Crisium, and so on. So Serenitatis would have been formed a little bit after Humorum and Nectaris, but probably a little bit before Mare Nubium. So you can sort of see that Mare Nubium's arc or curve at the edge of it kind of invades a little bit into Mare Serenitatis on the side. Later on, though, these depressions were then filled in with lava upwelling from the center of the moon. And what's interesting is that, as we'll see, the lava that filled Mare Serenitatis actually came in different phases and took quite a bit of time. And some reports suggest that even as recent as 1 billion years ago, it could have been still flooding with some basaltic lava. Now, the basins have these cool characteristics where they're roughly circular and they are kind of ringed. So let me go back to my map of the lunar geology here and you get a sense of this ring idea. And we can look at these objects through binoculars or telescopes, and you can start to look for the evidence of these ring systems. In some cases, they're pretty obvious. In other cases, they're a little more subtle. So we'll come back and deal with a little bit of this in detail. But basically, in terms of Mare Serenitatis, you'll find that this middle ring here is the most obvious one, and it's actually surrounded by, possibly, there's a little bit of controversy over whether this is actually, you know, that obvious to see or not. But this outer ring, which is the brown dotted line here, it's about 1,300 kilometers in diameter. And again, it's a little bit disagreed on by scientists. If it is there, though, it cuts through. Let me go back to my view of the other scene here. It kind of cuts through. Go to my close-up of. So it kind of comes on the outside, and it would consist of Manilius. So there's Manilius, and it would go down through Calipas and sort of take this outer kind of ring to it. But you may have noticed in this previous diagram that the Imbrium Basin ring, outer ring, it sort of bisects or chops off the outer ring of Mare Serenitatis. The main ring, though, the one that we kind of see when we look at it, is about 750 kilometers in diameter. And it starts down here at this mountain range called the Jemez Mountains. And then it runs up here sort of on the back side of the Caucasus Mountains. Okay. And then it goes along some unnamed highlands. There's actually a lot of parts of the moon that haven't been named yet. So if you think of any worthy recipients that need recognition, we could start applying to the IAU to get some more people recognized. Then it comes down through Rim Daniel here and the crater Daniel, and then down through Luther, which is here, sort of between these two. Comes down through Posidonius, this big crater, through Chacornac and Lemonnier, and sort of then down through Rima Littrow and sort of along the bottom. So that's kind of the 750 kilometer diameter ring. The inner ring, so the way that impact basins are formed, because you've got a kind of a softish mantle overlain by a thicker, more stiff crust, when the impactors come in and they dissipate their energy radially away from the impact site, you can create these ripples that are kind of like rings in a pond when you throw a pebble in a pond, except that in a pond, it's water all the way down from the surface down. Whereas on the moon, it's more like, I don't know, like pudding with a crust on it, or maybe a wedding cake with stiff fondant layer on top. So you can get a lot of sloshing in the under part, but on the top, you get a limited amount of action happening. And so these rings sort of get frozen into place that include the mountain sort of ranges on the edge, but then some other rings. So what's cool is that I can show you the interior rings, and they're actually better seen at low sun angles, or what I'm going to do is I'm going to switch over to a shaded topography view of them. Now I can see them a little bit better. So you can see these ripples, these crinkles kind of running along here, a bit less in the western side, but you can sort of make out a kind of a roughly circular set of wrinkle patterns that form the inner intersection of the ring. And we'll get into a little bit more about what those mean. The other neat thing about Mare Serenitatis, and I think I've got the gravity here, is that there's actually enhanced gravity underneath it. It's due to something called a mass concentration. Because the basaltic lava is denser and heavier and iron rich, it tends to pull on you more, so it produces stronger gravity where it's concentrated. And we think that in this case, we've got a combination of a lozenge, of lava, this basalt lava filling the bowl, plus underneath that, there's probably a plume of basalt that's kind of raised up underneath the basin from the moon's mantle, kind of locked in place there. And one of the evidences for the moon being so geologically quiet and for the moon to be, relatively stiff, I mean, the Earth's sort of pliable in a sense, its crust, is that these mass concentrations are sort of frozen in place. They don't dissipate. You'd think that they would kind of dissipate over time, but they haven't. So that's kind of further evidence of the moon's.
Speaking of which, I'm just going to slide the question we have here from James. Is there any molten lava remaining inside the moon? Do we know of that?
I don't know if we definitively know that, but I think that the very interior, the very center of the moon would still considered to be close to molten. I'm not sure though. Yeah.
And we're doing our next era of space exploration. We'll talk about this later, is going to the moon to learn more about it. So hopefully in the next decade or so, we learn a lot more about the structure on the inside of the moon. We can have a definitive answer of that.
Absolutely. Yeah, that's the whole point. And, the Mare Serenitatis was one of the Apollo mission landing sites, which we'll get into here in a bit. But it's almost an embarrassment of riches. Everybody has their favorite scientific mystery they'd like to unravel, and so there's a lot of competition for where to land. The Artemis missions, and you can talk a little bit more about the Artemis specials that you're running, is I think focused on the potential moon bases, which would be kind of the South Pole shadowed craters where there'd be water ice available and things like that. Right?
Mm-hmm. Yeah.
All right, let's go back to my previous view here, our regions. So the way you can identify a Mare Serenitatis just visually, without any telescope, without any binoculars, just looking up if you want to, is that it's kind of north central on the moon's, Earth facing hemisphere. And, people see different patterns when they look at the moon. So one pattern is this is the body of a rabbit, and then his kind of shoulder, and then his head, and these are kind of his ears curling around to the right. So that's one way of looking at it. The people in the southern hemisphere, they of course see the moon upside down, and they actually, in the Maori traditions, they actually see what we would call the rabbit's top half as a woman being pulled up into the sky and holding onto a giant tree. So if you turn the moon upside down and take a look at it, you get that legend there. That's a story for another day. And then there's the man in the moon idea. But for me, I always see Wilma Flintstone. And so this is her eye. She's kind of smiling towards Copernicus here. That's her eye. Her nose is kind of in this area. Her smile is here. Her chin, her throat, and then she's sort of got Tycho, the bright crater Tycho, as her pendant on her throat. And then Mare Serenitatis is the curl at the top of her hair. It's even the same shape. If you look up a picture of Wilma Flintstone, it's almost exactly the right shape for the curl at the top of her head. And then the rest of her hair is Mare Tranquillitatis and down from there. So that's what I see. And hopefully now I haven't infected too many people who look at the moon as well.
I've never seen it that way, but now it's like, maybe I can't unsee it.
Yeah. Now, let me just center the moon here, and I just want to demonstrate the best time of the month to look at the moon. So obviously the moon's terrain is best seen when it's in shadow or close to being shadowed. And so you can see that at first quarter, all of Mare Serenitatis is in sunlight. And so you're getting a really good combination of, some shadowed features due to the slanted sunlight. But really, the terminator starts crossing Mare Serenitatis, a couple of days ahead of first quarter. So you really want to get it. You get the east half, then you get the center part, and then at first quarter, you've got the whole Mare to look at. And that'll be, so that's why this is a great target, because it's up after dinner every month, every lunar month. It's like up at a convenient time of the day to spend time with the kids or whatever you want, looking at it with telescopes, binoculars, whatever you've got. And of course, when you get to the, after full moon and you get into the waning phase, you lose it after a couple of days after full moon, was the terminator reverses over it. Now, another thing to look at when you're paying attention to Mare Serenitatis, and it's especially obvious when the moon is a little bit fuller, is that not all Mare look the same in terms of their gray tone, their color. So you might notice that Mare Tranquillitatis looks darker on this image. It's also in real life a little bit more blue tinted. And that's because the basalts that flooded Mare Tranquillitatis were enriched in titanium, among other things. And that was one of the reasons why they chose this as Apollo 11 landing site, because it had anomalous chemistry in the basalt. And also because the landing site, which is where I'm pointing right now, sort of here, was kind of central to the moon's equator and meridian. And that made the orbital dynamics a little bit easier to manage when it's sort of a central target area. But yeah, you'll notice that Mare Serenitatis is definitely brighter compared to the Mare Tranquillitatis beside it. But you will, on closer look, notice that the edge of Mare Serenitatis is dark. And so we'll look at some close-up views of that in a little bit. The other neat thing is look for the ray system. So the moon, the younger craters on the moon are accompanied by these emanating ray systems. The most famous is Tycho here at the bottom. And the Tycho rays are very straight, they tend to be very straight and narrow. The ones around Copernicus and Kepler here tend to be a little more raggedy and a little bit shorter. But you can find these ray systems all over the place. We've got the asymmetrical set around the crater Proclus here. There's a neat little one, double ray around the crater Messier down here in Mare Fecunditatis. And there's a really prominent ray that streaks right through the middle of Mare Serenitatis. It goes through this crater here. Let me just switch over to the other view where I've got labels on things so you can see. So there's that ray I was talking about. And it runs through this crater called Menelaus, which is a more recent crater, and it does have rays emanating to the sort of west of it. Lunar west is to the left of the screen here. But there's a debate on whether this ray here is from Menelaus, which it's online with, or some people wonder if it's a Tycho ray, which I doubt, just because although it is the right direction, it does seem to be kind of strong where the others have petered out. So that's kind of an interesting mystery. I wondered whether it's even a ray from the other direction. So if you take the moon's globe and tilt it down, there are obviously rays coming down from the polar region. So maybe there's something, from here that emanated down and through the bright material over the dark Mare basalts. I'll pause talking every now and again in case you've got a question.
I think we are all good on questions. Just a reminder to everybody, we did previously have a webinar which you can access, Moon at Noon, that goes through all of the Explore the Moon targets, as well as we go into some more details on exactly how these rays are formed. It's way longer. It's a 6-week, half-an-hour episode if you really want to dive deep into the moon if this tickles your fancy after this session.
Absolutely. So just before we leave kind of the visual part of things, is I just wanted to go back to the topo here for a minute and just point out just what a steep cliff the Jemez mountain range makes. So I think these escarpments that you see along the southwestern edge of the Mare, they're about 2.5 kilometers tall. So it's really quite dramatic. Of course, the ones that are around Imbria are really fascinating to look at too and exciting. But hey, you know, Serenitatis has got its little set of the Jemez Mountains down here. All right, so let's switch over and sort of talk about what we can see in a telescope. And to do that, I'm going to actually change over to another program. And this is a really neat tool. And Samantha can put the link into the chat. It's a tool that NASA puts out called Moon Trek. Let me just switch over to this Moon Trek. And you can actually use it in a number of different modes. If you click down here on this little globe icon down to the lower left and open that up, you can see that you can present the map of the moon as a global map, sort of orthographic projection in a big rectangle. I'll just zoom out so you can see. Or you can turn it into a 3D globe, where you can literally just roll the moon around as I was just doing in Starry Night a moment ago. So there's our Mare Serenitatis there. And then you can also go over here to the right and you can use the base maps tool, and you could, it actually has an option to do zoomed in photos when you zoom in on, say, a lunar landing site or a moon probe. And I can show you an example of that if we go down into Apollo 17 region here. Let's see if that'll pick up. There you go. See this little kind of composite that's overlaid on it. It's kind of fun. This one's not a particularly good mosaic, so I'm actually going to switch this off and just use it as it is. So this is a great tool. And you can also switch on, let's see, where's my layers? You can also put in latitude, longitude, or moon locations. And there was a tool here. Oh, and if I go back to the global map, which I prefer in this case, then you also have the option of adding names. So just click on nomenclature, and that'll switch on the names. Then you can hide this if you're ready to go.
I think we need to take a time to appreciate how cool it is that we have access to this detailed images of the moon and how high quality they are. And you can take a tour of the moon from your computer. Because if you viewed the moon from a telescope, you get some good images, but nowhere near the fact we have all these views to access.
Yeah, and the other neat thing is that, because the moon is bright, easy to see, you don't need to worry about your night vision. Then there's no harm having a tablet or a computer or a light with a book, beside your telescope when you're out looking at the moon, because you're not really harming anything. And so, you can use tools like this to compare what you're seeing through the eyepiece and really drill down on the details. So talking about the things that you can see in a telescope now, first I'm going to talk about those wrinkles that I showed you a little while ago and what they look like when you're viewing them up close. So you can see here I've got a set of wrinkles that are visible on here on the eastern side of the Mare. And so this long sort of connected, winding set of wrinkles is actually nicknamed the Serpentine Ridge, but it's actually composed of a couple of different dorsa. So dorsa just mean ridges, wrinkles, like dorsal fin on a shark or a dolphin. So you think of a ridge on the animal's back. And so these are little ridges. And they tend to be, you know, these ones are sort of sinuous a little bit. They're divided in this case into a section at the south called Doris Lister. There's also a dorsum. So dorsa and dorsum, there's a singular and plural forms of the phrase. That connects up with a gap here to Dorsa Smirnov. And there's actually a crater that if you're following along this wrinkle ridge, you can look for a crater called Very. That crater is 5 kilometers across, so it gives you a sense of how, you know, how large you're seeing features on the moon when you're looking at it. They're about 10 kilometers wide, so you can see it's about double the width of the little crater, so 5 to 10 kilometers in diameter. They're only a few hundred meters in height, though, in relief off the plane of the Mare. If you follow Smirnov north, you'll find that it comes to a little crater here, and then it sort of splits. This is Posidonius Gamma, it's called. That's not a Y, that's a gamma, Greek letter gamma. And it splits, it kind of forms these Y shapes. So you can look for that. You'll find that big craters, many of the little craters near a big crater are just given the letters to associate them with the main crater. And again, that's another example where there's a lot of craters that have been assigned to the family of a bigger crater, but they could be split off and assigned a new name to another scientist, or, you know, we need to get more of the, you know, more of the lady scientists and researchers
I was going to
representing
say,
on the moon, don't we? Right? So we should get
there's
on
less than 50 impact craters named after female scientists.
and a lot of them are on the far side.
Sorry?
I said a lot of them are on the far side too, and not visible for us.
See, that's crazy. And look at how many craters there are. We got lots to name.
Okay. In the middle, and again, this is not, let me just go back to the other view so you can see the other. Let's see. Yeah, I'm going to go back to the, oops, how can I get out of Moon Trek here? I just want to go back here for a second. I'm going to do this. Okay. So Dorsa Mazara is kind of in the middle. I'm going to go back to my topo map here. So this one kind of in the middle is called Azara. And that's a bit more subtle. So you can see it's there. It's a bit shorter, a bit more subtle, kind of in the center. And then to the southwest, there's a really extensive set of them. So there's Dorsum Buckland, there's Dorsum von Cotta, and you can follow a whole set of these around. And remember, these are more or less parallel to the circumference of the basin. Now, what are they caused by? So what happens is that as the lava fills up the basin, it's heavier dense rock. So it tends to weigh the moon's crust down. And then at some point, the moon recovers and you get isostatic rebound. And when you get that isostatic rebound, then you can get wrinkling. So that's how you get these rings of wrinkles produced by that. You can also get it produced by various epochs of flooding, where the new lava tends to pool in the middle. And so you get a new section layering over an older section. We'll come back to that in a bit. Here's a cool map that Samantha can put in the chat. Let's see if I can open this and bring this up. Here we go. So this is Lunar Map 42, and this is what's called a lunar shaded relief map. And this really gives you a picture. There's that Y I talked about, and all the various wrinkles that are visible to see under low light conditions. So that's a neat one. All right, so let's talk a little bit about these lava flows that I was mentioning. So now in this view, you can really see there's a sharp boundary here between brighter lava on the north and darker lava on the south. And in fact, the darker lava kind of matches Mare Tranquillitatis to the south. So there's a possibility that the flooding that filled Tranquillitatis kind of inundated part of Serenitatis. You can also get a dark area kind of along here and then up through kind of this area. So you can see I'm just tracing the sort of boundary between brighter and darker basalt. Let's kind of go like that. So the lava in the center is between 3 and 6 kilometers thick, and then it thins as you come to the edge. And what you're actually seeing is different eras of flooding. So the idea here is that the darker lavas were there first, and then 700-800 million years later, eventually a lighter, maybe less titanium-rich lava basalt came in and filled the center of the bowl, and you left with this exposed rim of the older lava around the outside edge. So that's kind of a fun way to understand a little bit better about how it's all assembled by looking at these different variations. The other neat thing is that, I don't know if I can come back to this one more time, is that you might even notice that the edge I'm tracing out here is that the dark lavas are actually a little bit higher in elevation than the lighter lavas. So not quite sure about that, but that's another aspect of this.
Now, question for me,
Yep.
not for anyone else. How much do we know these concepts compared to what we see happens on Earth? How are those connected? How we learn about the moon versus the processes we know happen here?
Yeah, well, we can find analogs to some of these features, of course, on the Earth, but then we also have differences that we don't experience, as I was saying before about the overall more stiffness of the lunar crust versus the Earth's crust. The Earth's crust is very water-filled. There's a lot of water in our crust that makes it pliable and produces effects that we don't get on the moon. And plus, the moon doesn't have plate tectonics and things like that because its internal engine has died down, idle. But yeah, so there's that side of it. So looking for analogous things, and of course, on Earth, our impact sites get obliterated over time, so we don't have the time capsules that the moon offers us. And in fact, that's one of the real driving reasons to explore the moon with humans being there, is because we're getting this time capsule of the history of the solar system. We can understand better things that may have happened to the Earth but have been wiped clean by water and wind and plate tectonics. Is that kind of what you mean?
Yeah, I just find this incredibly interesting as someone who has a background in science, and I'm sure you can relate with me, and how the differences and how we learn from each other and connect them. So I was wondering, yeah.
So another neat thing that's going on here is that not all dark lava is equal. And what you're going to notice if I zoom in here on the southwestern corner is that you notice that the dark area actually is on the hills. And what's happening here is that this is not dark lava. This is actually pyroclastic ash deposits. So if you've heard of the dark glassy beads, the orange glass and the different colored glasses that the Apollo astronauts found, I'll switch over to that here in a second. But we think that at some point there was volcanism happening in the southwestern quadrant of Mare Serenitatis. It blew out these glassy pyroclastic debris, dark debris, and it kind of settled like a coating over everything, including part of the Mare and part of the Hamish Mountains. And so that's why you get this dark mantling. So it's called a dark mantling deposit in the sense of a mantle being something covering something else. So around Rimae Sulpicius Gallus, try to, when you've got your telescope out, see if you can notice that. So you've got the regular dark lava here on the plains, but you've also got these dark mantling in the other. And you can see other little bits of that here and there in these little lacus. So these lacus features are lakes, Latin for lakes. So Lacus felicitatis, ODI. ODI is like odorous, like death, I think. Dolores and so on. But yeah, going on over to the other side, we get Apollo 17 area. So the Apollo 17 landing site was chosen. These are the Taurus Mountains up in this area, and then this is the crater named Littrow. So the Apollo landing site is called the Taurus Littrow area. basically. And you can see when you look at this that you've also got extra dark features on some of these sections. And again, that's more of this dark mantling deposit. And in fact, the astronauts did recover this glassy pyroclastic material and brought it back. They actually dated it at 3.48 billion years. So I said that the Mare was formed around, what did I say, 3.6, something like 3.6 billion years. Then the lavas were inundating it for the next 700-800 million years. And then somewhere during that process, we got an epoch of volcanism, 3.48, where those mantle deposits were put down. The other thing that the Apollo 17 landing site was chosen in this area because of those dark deposits, and also because this section of the moon is on the curve of that main ring. So they wanted to land at the edge of the Serenitatis basin along that main ring. So this is the area they chose. And they actually landed between these two sort of peaks. There's one called the North Massive and a South Massive. Those are peaks. And people wondered whether they were volcanoes or what they might be, but they turned out that they were just giant mounds of breccia meaning broken up rock, sort of cemented together, melt breccia that happened when the basin was excavated. This violent energy broke up all the rock and sort of pasted or melted it all together into a jumble, and that's what you get as this melt breccia. So they brought samples of that back, and they went and they looked at a landslide. So you can see there's a whitish area here. I think it's around here. Some of these whiter areas turned out to be landslides, and when they brought back the samples of that and age dated them, they turned out to be 109 million years old. So that's curious, 109 million years old. Well, what happened 109-ish million years ago is Tycho was formed. There's Tycho. So they think that 109 million year rock is ejecta from Tycho that landed, or may have triggered a landslide or something around that time. So that's kind of interesting. All right, what else have we got to talk about in this area? Let's see. So you're going to look for, if you're checking this out, of course, you can't see the Apollo equipment with our, Earth-based telescopes, but it's sort of fun to identify the features in the general area. So look for the crater Vitruvius, which will be fairly obvious, and Maraldi, which is kind of a similar size, but it's sort of broken edged, whereas this is a nice sharp edge. And then Littrow, the crater Littrow, is sort of also mostly obliterated. And if you find these three, then you know that Apollo 17 is kind of tucked in between the two westerly ones. And then I think it would be cool from here is to start kind of tracing around the outer edge of the basin. So you're going to look for a few cool things. So for example, from here, you can look for more wrinkle ridges. So this is Dorsa Aldrovandi coming up here. But you've also get these, so these are ridges, but look at, you also get these depressions. See these sinuous depressions? And there are probably about 10 kilometers across as well. There's a whole bunch of them in here. And what's happening is that, and there's cracks here. So what happens is that you get some rebound, but you also get some settling in the basin. And when you get settling in the basin, you get cracks around the rim. As the basin settles, it opens cracks at the edge. And so if you trace the edge of Mare Serenitatis, you'll find all of these cracks running much of the way around the basin. In a lot of cases, you can find straightforward normal cracks or fissures, but you can also get grabens where you've had parallel cracks which separated and the crust between them dropped lower and produced troughs. And so if you follow north from here, you can follow Aldrovandi, you can follow another graben up here, up towards Le Monnier. So when you get to crater Le Monnier, you want to notice that crater Le Monnier got flooded by the basalt that filled Mare Serenitatis. So the lower western rim was low enough for the lava to flood in. And what tended to happen is that many of these craters were already there when the basin was formed, and then they got tilted downwards towards the center of the basin. And so that would lower the interior edge and allow the basalt to flood in. And if you look closely, you can sometimes sort of get a sense of the old edge running through it, Le Monnier. Another one of these great cracks running north-south through the edge of Le Monnier, coming up through here. And to look for the parallel one, so this is Rime Shakornak, which comes up a little bit east of it. These kind of run parallel. And there's another one over here named Bond. And so again, these are all sort of parallel to the edge of the basin, these cracks. Keep going up. We'll go past Posidonius and come back to Posidonius. Keep going. If you get to the northeastern part of the basin, then you can find more of these cracks running now more east-west. So follow those along. And again, I can come back to the, if you want to know what the labels of these are, go back to my features map here. So here we go. Oops. So that crack I was just showing you running sort of east-west, that's Rime Daniel, named after the crater Daniel. And then if you run a little bit further west from there, then you get a whole range of them, extensive set of them, cutting all the way through. Again, these mountains are unnamed, so if you have any ideas, keep them in mind. Around the crater Luther. So there are some to the north and there are some to the south. And then as we keep going around the edge, then we get over here to the northwestern edge of the basin, and we have this crater Calipas. And Calipas has given its name to this Rima Calipas. Now, when you see a curved Rima like this, it's not a crack that's opened in the sense of the word that we used before. This is called a sinuous rill or Rima, and it's produced by generally lava flowing through and then later draining out, leaving a channel behind. You can see it's sort of got main channel and then branching effects. So that's kind of the clue that it's a lava channel. I think not many of the rills or rimae near the western side. And then if you come in up close again, you can start picking up some other more details, bringing us all the way back around to that dark mantle deposit. So those are fun ways of kind of touring around and reading the geology of the basin. Any other questions up to now?
We have some general questions. I just didn't want to pop in, but one is, do you know why all the mares are on the Earth-facing side compared to the far side of the moon?
I think it has to do with the tidal effects of the moon and the Earth system. There's only a few percent of the Mare are on the far side. So it's been a while since I looked into this, but there's a formula for when the effects of, there's a formula for calculating how long it takes to tidally lock. And it's dictated by the mass of the two bodies and things like that. And so the moon has tried to slow the Earth's rotation, and the Earth has tried to slow the moon's rotation to the point where the Earth being more massive, it won first. Mm-hmm. So the moon is now locked at rotating once per lunar month facing the Earth. And that happened relatively early after the moon was formed, I think, very early in the process. So the moon probably was already in this position. It was closer to the Earth at that time. And so it probably something to do with the gravity, and the pull of the Earth has preferentially caused the Mare to be on the Earth-facing side. Not sure if it's 100% understood yet, but I think that's kind of the general idea.
From what I remember when this question was discussed over a year ago, that was the same kind of thing talked about. A couple more. A few years ago, NASA launched a pair of spacecraft that orbited and measured the pull of gravity at points around their circumference. as it does vary. Approximately 1/6 Earth, but not consistent. This was to do a lander descent calculations for different areas of the moon. Do you know if this data is available or where they can read more about it?
So,
Not sure if you've looked in on it.
so this anomalous moon map is partly derived from the Grail spacecraft mission, right? So what happens is that, you're driving along the highway on a gusty day, and you see the car ahead of you do a little jiggle, and you know that it hit a gust of wind, and then a second or two later you get it. And so the two spacecraft were following one another around the moon. And when the second spacecraft saw the first spacecraft kind of dip, it was flying over something more where there was more gravity. So it was perturbing its orbit. And so they could, by calculating the difference in the motion of the two spacecrafts, they could work out the details of the moon's global gravity. So that's what this map is. And so that tiny change in gravity, or the change in gravity produces tiny deflections in the orbiting spacecraft. And so we want to use that information to plan for precise landing on the moon, because you need to be able to account for little jogs and things that are going to happen to you when you're getting close to the moon's surface. I think that's what you mean, isn't it?
Yeah. And so you're using, just a reminder, Sky Safari is what you're using to find these images?
This is Starry Night.
Starry Night. Oh, I'm sorry.
Yeah.
Sorry to someone who I said Sky Safari. It's Starry Night. So if you want to use a similar program that Chris has up here, it's Starry Night. And we have, do we know which craters have water? Is there a list?
Yeah, so go back to my topo map here for a second.
All the questions are coming in now. Let me know if you want me to split them up for.
No problem.
Two.
So the idea, let me just bring on, I'm actually going to show you the moon's pole. Let me just bring on the pole here. Here we go. Go back to favorites. Okay, here, like this. So this color-coded view I'm showing you is blue areas are low elevation, and purplish pinks are high elevation, and then greens and yellows are in between. And you can see here that there are a number of craters near the lunar south pole, which are low elevation, and many of them that are deep would never get any sunlight shining on their bottoms. And so any water that would ever have been deposited on the moon, and moon would have been hit by comets as well as asteroids and rocky bodies. And so if a comet were to hit the moon, the water would be kind of distributed on the moon, and then it would sublimate for the most part. But there are places where the sun wouldn't be shining, and so the water would not be dissociated and would not be driven off. And so we know that there are craters with substantial water in them, especially near the poles of the moon, South Pole, North Pole, where the sunlight just can't get over the rims and shine into them and dry up the water, so to speak. So that's the idea. So the Artemis mission plan is to go to Shackleton. Let me see if I can mark Shackleton on here.
We also have a Canadian lunar rover will be looking at part of that mission as well in the future of moon exploration.
Here we go.
Looking at the South Pole. There we are.
So there's Shackleton, pretty much right at the lunar South Pole. And it's one of a bunch that are known to have water. And one of the ways that they do this is that what they do is they look at the sunlight reflected off the moon, and the light has a fingerprint that's controlled by the basically the material it reflects off of, and they can actually analyze. It's kind of like a mass spectrometer. They can actually analyze the chemical composition of the rock that's reflected that light back to the detector. And so they can do things like look for concentrations of hydrogen, concentrations of oxygen. That's how the Sophia spacecraft was able to find anomalously high concentrations of water atoms in the Calipas crater. It was announced a couple of years ago. Yeah, good questions.
Okay, thank you for that. Carl is asking, what would happen with Earth-Moon gravitational or magnetic equilibrium if we start mining the moon? That's an interesting question. I have never thought about that before. I couldn't imagine.
Would it
Too
affect,
much.
would it affect the moon's gravity? No.
No, gravity is like we all have gravity and attraction, but you need very, very massive bodies to make real big
Yeah.
effects. So I think we would have to like mine half the moon to make it seem to affect something.
So in my former life, I was a mineral exploration geophysicist. And so I visited quite a few mines in my day. And, you know, you think of oftentimes a mine being kind of destructive and disruptive of the environment, which it can be, yes. But if you ever get in a small plane and fly from, say, Sudbury north into Northern Ontario or into the remote parts of the country where the mines are, you realize just how tiny they are. They really, in the grand scheme of things, they're really extracting very little rock and material out of the earth compared to the bulk of the earth. The moon would be the same. So mining material in the moon. I would be concerned about, you know, aesthetics. You want them to not make a mess of it too much, but really most mines have a pretty small footprint. The smallest thing that you can see with your telescope on the moon is about 1 kilometer across. And not very many mines on Earth are more than a few kilometers kind of in extent, you know, plus they might have tailings basins and things. So 5 or 10 kilometers. So you're looking at, you know, a patch on the moon much bigger than a little crater.
Maybe in the future, people will be pointing out mine sites on the moon as well as craters.
Yeah.
Well,
if anybody's interested in this program, the Starry Night program, which I'll just show you one more thing here, which is fun. So if I right click on the moon, I can look for elemental abundances of all these metals and materials. So if I want to say, well, where's all the magnesium on the moon? There's a map for that. So that's kind of fun. So that would be something you'd use if you wanted to plan, you know, where you wanted to extract certain metals or materials. Thorium is fun. So thorium is a radioactive element. But yeah. All right.
One last I'm just Anga, could you please clarify your question about the stratosphere and orbiting? But you can do that in the chat. And Bernie, when did the moon become gravitationally bound or tidally locked to the Earth?
So I don't have the number memorized, but if the moon is
I'm seeing numbers like in the billions of years, like 50
almost
billion.
the moon is almost 4 billion years old. My understanding is that the object that sort of hit the Earth and blew off the material that coalesced into the moon, that coalescing time frame was rather short. I mean, it was hundreds or thousands of years for the moon to coalesce. And so it wouldn't have taken very long. The moon is smaller than you might think. You could fit the moon between Vancouver and Kingston, Ontario. So it's only 27% the diameter of the Earth. So it definitely loses the battle when it comes to the Earth's gravity versus the moon. All right, go ahead.
Okay. We can move on and we can answer some of these questions later. I'll let you keep going.
Yeah, let me cover a couple more things and then we'll switch over to our messy minutes or some more questions. I just want to inspire people to take a look at a few more fun things, interesting things. So this big crater is one of the most interesting craters in the Serenitatis area, if not the moon itself. It's Posidonius. Posidonius was named after the Greek philosopher Posidonius of Apamea. And so it's called a floor fractured crater. That's because it's got this complex floor with cracks and rills in it. It's 95 kilometers across. The rim is only about 2.3 kilometers above the floor in the middle, which is lower than it should be. So we actually have mathematical models that predict, given a certain depth and diameter, how high the rim should be when it's brand new, and something has happened. So what we think happened is that the part of the tectonics that created the Serenitatis basin probably partially filled in the floor of Posidonius, raised its floor and also domed it a little bit. So it's almost even like a dome shape where the center is raised up. And another clue of that is that you can see that the western edge of the rim is partially breached, so the lava could flood in. And also this set of little ridges, this little set of dots that I'm pointing to here, that's the old peak in the middle of the crater, but it's almost completely inundated by the filling in of the floor of the crater. So it filled in almost to the point where it covered up the central peak. And one of the neat things I read about is that these two little peaks here in the northwest, as viewed from Earth, they're about 1 arcsecond apart. And so if you want to judge the seeing conditions, how small a feature you're getting through your telescope, see if you can resolve the two peaks. That's 1 arcsecond. And how much more?
The interesting thing, I'm just looking back at my notes for my moon observing, and this one, I did view it a few further away from the terminus, but it looked apparently flat, very flat looking to me. And I only really noticed the Posidonius A and Posidonius B as other features in it when I observed it from, I had a Barlow and 20mm lens.
So you want to, if you want to see all the cool extra features, then you want to catch it a couple of days before first quarter, because at that point it's in the slanted sunlight, but the rest of the Mare hasn't been lit yet. You'll find that this curved ridge here, this is probably a landslide where the original edge of the crater slumped, pulled away from the outside edge. You've also got these linear rills or rimi running every which way. And a number of these have Greek letters to them. So there's a bunch of straight ones, and these are about a kilometer in diameter, kilometer width. So they vary a little bit in width. And then look at this really cool, sinuous one, winding around the edge and then running down here. Really amazing looking. Not sure the explanation for that. It almost has that look of a lava tube sort of effect, but I'm not sure they know exactly what happened. That's a good one to send human beings to explore. I think that'd be neat. Let's see what else. And then there's a bunch of little craters to the north of it that are exciting. I mentioned, let me go back here to my other one. Go back to my features labeled here. So that's Posidonius. And then we get Luther. So Luther is called basically a type 1, or a most simple type of crater. It's basically a simple bowl shape. Oops. So it's a sharp edge rim and a curved bottom to it. So it's called a type 1 crater, named after an astronomer from Germany called Robert Luther. And then Linnaeus. So Linnaeus is another one that a lot of observing programs ask you to look for in Mare Serenitatis. Linnaeus is a teeny little crater. It's only, 2.5 kilometers across and 600 meters deep. And it's actually got, because it's a recent crater, it's got a bright halo of material around it. And so there are times when, you could see the little crater, and other times you just see the bright glow of the halo around it. So especially at high illumination, it becomes one of the little bright spots on the moon when the moon is nearly full. That's named after the botanist Carl Linnaeus, if anybody's interested. I talked about Bessel a little while ago. That's that one that the ray goes through. It's got kind of a flat bottom, almost like a pie plate. So that's named after Friedrich Wilhelm Bessel. We have Plinius. Where's Plinius? So Plinius is down here, just below the dark and light lava edge. So Plinius, that's 43 kilometers across. It's got collapsed rim sections, and it also has a little pit in the center of it. Menelaus is another neat one. Oops, here's Menelaus or Menelaus. So Menelaus likely is the source of these rays that go to the south. And then let's see what else we can look at. That's basically it. So, I encourage people to go out and take a deeper look at some of these areas. And if you like this kind of a deep dive, there are a few other spots in the moon we could cover on a future session.
I also encourage a lot of the Bessel and Posidonius and Plinius. Those are all on our Explore the Moon list of features. So if you're looking for a good list of features on the moon, start with our Explore the Moon certificate. If you think that's too easy for you, you do what Chris Vaughn is doing right now, and he is doing the Isabel Williams, which really gets you to look a little bit more deeper at the ridges of the craters and the smaller features that we have pointed out. So that's more of our challenging one. And how many objects are on that list?
It's between 500 and 600 individual things to see on the moon.
So yeah, that's for the experts.
I have 11 left.
Oh my goodness. We have to have a little party, celebrate. Tell us when you get the certificate.
All right.
So we'll go back to some questions, and then
Sure.
we're going to talk a little bit about the new age of moon exploration, and we'll move into our messy minutes after that. Sound good, Chris?
Yep.
Okay, so does the moon have a magnetic field?
Very little, very little. Let's see. I can show you the magnetic field here. I thought it was in here. Maybe it's not. Guess not. Yeah, for a magnetic field, you need a dynamo. So you can have two different kinds of magnetic field. You can have a actively generated magnetic field produced by a dynamo in the core, which is what the Earth has. And then you can have leftover magnetism that was locked into rocks when there was a dynamo that'll stick around later. And so that's the difference between sort of a big magnetic field with, the apple core shape field lines around it, or just, being able to walk around with a magnetometer and get some subtle differences. So the moon just has the subtle variations. One of the more interesting spots on the moon that has magnetic field evidence is over here. So when you get towards full moon, you want to look at the western side of Oceanus Procellarum. So there's Copernicus, Kepler, Archimedes, and then down here, there's a funny bright patch, and it's kind of like a tadpole shape. And it's called the Reiner Gamma Swirl. And it's kind of a bright stain on the moon. It's flat, there's no topography. And the scientists think there's a strong magnetic field underneath the swirl. And astronomers think that that magnetic field stopped the moon's cosmic rays from darkening the moon crust there. And so it kept it bright. So that's a localized bit of magnetism just in that spot.
Interesting about how much we know about the moon, but also that just raises more and more questions and things to explore continually. Another question. I seem to remember a NASA proposed mission to redirect an asteroid to orbit the moon. It seemed like a very dangerous idea to me at the time, but brought up thoughts of terraforming the moon. I imagine that the perception contributed to the decision to cancel the mission. Is there anyone thinking of terraforming the moon? I know we're on a lunar base. I haven't in any of my readings thought about terraforming in terms of we're going to use the moon to really practice what it's like to live off of Earth. But I don't think that goes so far as terraforming it to what we're thinking.
So the problem with terraforming is that in order to make the moon habitable in that sense, it has to have an atmosphere. In order to have an atmosphere, it's got to be able to hold on to the gases, because the sun is constantly wanting to boil them away, push them away with the solar wind, or just dissociate them with the solar radiation. So the Earth has enough gravity to grip onto its atmosphere and a magnetic field that deflects the sun's pummeling. Whereas a planet like Mars is half the size of the Earth, so its gravity is lower. Plus, it doesn't have a magnetic field anymore because its internal dynamo, it cooled down and its internal dynamo stopped. So its magnetic field is nearly nulled out. And so it's not protected from the sun's pummeling. And so much of Mars, which may have been wetter, may have had a thicker atmosphere, has been dried up and kind of thinned out. The moon is way down the list of that. So I would be shocked if we could ever terraform the moon. We would almost have to create an artificial magnetic field around it or something like that, and do something like a force field to hold everything in. So I just don't know if that's possible.
We have a theoretical question. What would happen if the moon orbited way closer to Earth, like atmosphere, like the far atmosphere? How would that I would assume, when I'm thinking about this, it would definitely change the pull, and oceans, like tides, would be so much bigger.
Yeah, it would definitely affect the tides severely, and it would also potentially produce a lot more earthquakes, tremors, that kind of thing, the tidal pulls. The moon used to be much closer, it was much closer, and it's actually getting farther from the Earth by about, I think it's a centimeter or two per year. It's about, I think I figured out that in the time it takes for an adult to grow up, the moon would be about as farther away than that adult's height.
Interesting. I like that relationship.
Yeah.
One last question, and then we'll answer some of the questions about filters that I see going on in the chat. Were there any anthrocytes encountered on this side of the moon? Anorthosites.
Anorthosite?
Yeah.
Yeah. So all these bright areas, the battered highland bright areas, those are anorthosite. So this is all anorthosite. Yeah. Yeah. So anorthosite is basically an aluminum silicate rock. So it's got aluminum, oxygen, bit of water in there as well. So that's what it is.
In terms, we have some questions about filters. So color filters are helpful. I'm sure Chris can go a little bit more on his experience, but as a beginner with the moon, I found as long as I was looking near the terminator, I could just use no filter and see a lot of these features. The trouble really started I had to put on sunglasses. That didn't really work when it got full and I was trying to view the full moon. And that prompted me to buy a variable moon filter. But what other filters could you use that people might have in their stash that would help view the moon?
So if you don't have a filter at hand, you could try masking your aperture a little bit. As long as if you have a refractor, just try to put a cap over your telescope with a hole in it that's kind of centered, a little smaller than your full opening. That'll cut down the light quite a bit. Or if you have a reflector telescope with secondary vanes, just swing the opening so that it's between a pair of the vanes, and you're just effectively giving yourself a smaller telescope. Make the moon dimmer. So you could do that. Just cardboard, anything will work. You could just use cardboard or plastic or anything you have. But the variable filters are fantastic because you can dial them up to max when the moon is full and then partially when the moon is half, that kind of thing.
So color filters, basically what I understand is you're just really trying to block more of the light coming through it. So if you had a color filter, would that help at all?
Anything that'll cut the brightness will help some. There may be some features that are enhanced using certain colors. Off the top of my head, I don't recall what those are, but we can look that up for a future session.
Okay, one last question and then we'll take 4 minutes and then we'll move on. We'll have our last 15 minutes, messy minutes. Does the moon move through any residual atmosphere from the Earth? I think it's way out of the Earth atmosphere.
Yeah, not really.
Yeah, I mean, theoretically, it's like, it dissipates, maybe like one, but yeah. It's quite what we call our atmosphere ends significantly before the moon.
Yeah, so let me just show my info here.
But the ISS is still technically in the Earth's atmosphere. It's in space, but it's also.
Yeah. So the, oops, is that right? That's not right. So the moon, oh, I need to go onto the ground here. Let's do this. So the International Space Station is only about 400 kilometers above the Earth, and it gets some of the atoms that are sort of knocking around to the top of the atmosphere, but effectively not that much. It needs a boost now and again because of a little bit of friction with the Earth's atmosphere. And the moon is so much farther. So let's just do here. Let's just give you the number. So the moon is,
I think it takes a couple days to get to the moon.
nearly 400,000 kilometers away versus 400 kilometers away. So yeah, there's effectively no air out there where the moon is to bother it. There might be the odd atom here and there bopping around, but nothing to speak of.
Oh, I feel like we can go on forever about the moon. There's so many questions. So I appreciate all the questions coming in, but just so we have enough time for messy minutes and to quickly chat about what we are doing. This in general was a really cool deep dive, but it came at a really good time because, as we've mentioned a couple times, we have the Artemis missions program is starting. I think they're looking right now to send up their kind of test flight with no human participants on it, just to test all the equipment in June this year. They're doing a wet launch this month. So it's very new. And this is really cool because this is launching the next stage in space exploration. We're using the moon kind of they're planning to use the moon as a launching off point to learn how to, like the ISS is so close to Earth, we ship food back and forth. But if we have a base on the moon, that really gives us a better experience and helps us learn how to do more deep space exploration, as well as having a place to do research on it. So this is a really cool year. Canada is one of the space agencies, Canadian Space Agency, involved. We're contributing the Canadarm3 to a space station that will eventually be orbiting the moon, which will be used as a waypoint to just for astronauts to travel back and forth from the moon. Super exciting. Telling you all of this because this is basically humanity's return to the moon, and RASC is celebrating this. As people at Toronto Centre already has had their first moon viewing party, but if you're interested in participating in these celebrations, we have a variety of ways for you to learn about the moon, get to find people to view it with, and we kind of classifying this as Artemis parties, because it's the Artemis mission. On that link I just sent you, I will share my screen really quickly. Oh my gosh, I lost my. So we have a lot of different options. You can go here around the quarter moon, which we have a couple. We have all these moon ape themed events. So there's some are in person, some of them are online. If you're in Yukon, you had at your party yesterday. And the next online one is coming up on Saturday. We also run International Astronomy Day. We're going to be doing a huge celebration. A bunch of different centers are going to be going. So that's the general theme. We also are encouraging everyone to submit their images of the moon. So if you go ahead and look at the moon or sketch something or do anything, submit it to us. And we're going to feature it on your social media, our website, and maybe at one of the Artemis celebrations. I will also point out too that we have we are doing a sketching of the moon. So someone mentioned in the chat that someone had drawn all the impact craters named after females. That was Bettina Forget, and she is an artist that she's artist in resident program director at the SETI Institute, and she is going to be leading a tutorial on how to sketch the moon and impact craters and go through tips and tricks. This is happening this Thursday, the 14th at 6 p.m. Eastern time. And so you can register via Zoom. You can go to that page. It's on those event listing pages, or you can tune in via YouTube. And it's a really cool thing another way to explore your viewing of the moon. Now, if you tuned into the moon at noon, you saw me doing all my badly, like she's going to do it way better than I am. But I have used just even on my iPad sketched almost all of my images of the moon, as you can see here. And they start from being, when I'm actually looking at the eyepiece, looking like this, very, and this is what comes with the eyepiece. I shade in the darker and lighter spots. I can label them. I almost forgot to sketch in Herschel apparently. And then and then you can make them nicer. So let's pick a little meaty. I was saying I looked at, this is the one we saw, Posidonius here. That was my sketch of it. So if you're interested in learning, he told you, it has not a lot of detail. But if you're
worth revisiting.
Sorry?
It's worth revisiting then.
Yes, exactly. I need to go revisit it. I think I was just trying to power through all the objects. So if you're interested in learning something about that, we'd love for you to join us. And throughout all these, we're going to be talking and answering questions about our humanity's return to the moon. This is something we're partnering with the Canadian Space Agency to do as well.
Yeah, the Toronto Center already did ours a few days ago, so it's already on YouTube if you want to check out Toronto's contribution.
Yeah, so, and as Douglas said in here, Artemis 2 will have a Canadian astronaut on it as well. So this is just Artemis 1, but all the first few missions are supposed to happen in the first few years. And yeah, look up a center near you, check out Toronto's one online if you missed one. Lots of opportunities. So now let's move into, and let me just spiel, it's Messier minutes, but it's a little bit of shorter of a section today.
I just want to say one thing before we move on. I forgot to say is that the Apollo 17 landing site, look for a little crater named Clerk just to the upper left in the northeast. And that is named after Agnes Mary Clerk, a 19th century astronomer. So that's named after a lady. So there you go. So check that one out. Okay, Messier minutes. We're only going to do two this week because we've got a bright moon in the sky. And so I picked two bright objects that we can cover. And then we're going to slow it down a little bit and pace ourselves into the summer. So we're going to wrap up the spring Messier targets, which is a lengthy list, over the next few sessions. And then we'll be ready to tackle the summer ones when they come into view. So the two we're going to cover this week are these two yellow symbols, which are globular star clusters. So we have Messier 3 and Messier 53. So Messier 3, center this up for everybody. This is actually a pretty bright one. What I'm going to do is I'll show you the simulated view through a 6-inch Newtonian reflector telescope with a 26mm Plössl lens. I'm just going to switch on the deep sky image and turn off the stars here so you can get a sense of it. So it's a pretty bright globular cluster. It's near the border between Canes Venatici, Bootes, and Coma Berenices. It's about 33,900 light years away. And it's just bright enough to see with your unaided eyes if you're in a dark site. So if you get away on a moonless night in a dark site, you could try looking for it with your unaided eyes. Definitely binoculars will work, or any size telescope, even from the suburbs, it's bright enough to see from there. The way you look for it is you want to look, my trick is to spot it. Let's see, I said midway between Arcturus. So if I get my little measuring tool here, between Arcturus and the double star Coracorae. It's right on the line joining those two stars, and it's about midway along between them. When you're looking at it, you want to look for, there's a little triangle of stars around it, kind of a little trio of stars around it, which you can look for. You want to notice whether or not you see any variations in its shape. You want to look for, any details that you can, and how do the stars, concentrate or not concentrate? Is the halo sparse? Is it bright evenly all the way through? That kind of thing you want to look for. And you can check out this little double star right here alongside it too. This is 151 BPM, beta PM. Okay, so that's M3. Just bring these back on here. M53 is kind of easier and harder at the same time. It's easy because it's less than a degree from this star diadem, or Alpha Coma Berenices. But unfortunately, Alpha Coma Berenices is not that bright of a star. It's only magnitude 4.3. What you can do to find it at least to find the star first, is to start at Arcturus, look for his knee, Murfrid, and just sort of triple that distance. And that'll get you in the neighborhood of Diadem. And then you can look for M53 tucked in beside it. Let me just center M53 up and show you in the telescope view here. So you can see it's smaller than M3 was. So you're not going to be able to see this one with unaided eyes, but definitely should be able to, maybe binoculars, but definitely any size of a telescope, especially if you can get away from the city lights. You want to look for the stars around it. So there's nice, interesting little star patterns around it that you can look out, and you can use these to help focus as well. And there's also another object nearby. So let me just bring up my controls here and add the NGC objects. And I'll come out. So there's just center this up here. So there's the star Diadem. So they'll share the eyepiece view. You can find the Alpha Coma Berenices star and look for M53 nearby. Let me just bring up. So there's M53 near Diadem. And then a little jog to the south is another globular cluster, a little fainter one called NGC 5053. So you can check out for that. Again, that's sort of what you want to look for, is the shape of it, how the stars are concentrated, and that sort of aspect of things. So that's it, just 2 for today.
Nice and easy this week. If anybody has any questions, throw them in the chat. If you ended up seeing anything with our Virgo tour, if you ended up looking there, let us know. I'm really curious. The Virgo cluster we did last week. That was my challenge to you all. I didn't, but it was too cloudy for me, so.
Yeah. Next, so in 2 weeks, when we come back, we're going to do a deep dive into the constellation of Leo. And I'll talk about kind of the history and the story behind each of the main stars and the deep sky objects that are in that constellation. And there's some surprises that we'll have, so that'll be fun. And hopefully I'll spend some time giving you some more tips on viewing galaxies and some tricks and things you can do with Stellarium to help you with that.
We have no more questions about Messier Minutes. I want to say thank you all for coming to another episode of Insider's Guide. As always, all of these targets we discussed with Messier Minutes is on ras.ca/Messier-minutes and with the finder charts and some quick questions that Chris posed to you there. And we hope that to see you next week, 2 weeks from now. Have a good long weekend, everybody.
Yes, the full moon on Saturday. That's the one that triggers Easter. So we'll see you in 2 weeks.